All right, we're still continuing to work with radicals. I just want to go over on those basic pieces of what we want to look for. Remember, when we're talking about radicals, we're looking at the principal square root here, so I'm only looking at the positive square root. And here's where I really want to focus right now, that when we're in simplest form, no radicands have perfect square factors other than 1, no radicands contain fractions, and no radicands appear in the denominator. So those are the kind of the things I want to pay attention to as I'm simplifying and continuing to work with my operations of radicals. We do want to pay attention to this when we're working with variables. We're going to kind of switch gears a little bit and focus more on constants, integers, as we work with this, but that's still kind of in our toolbox there. All right, so we are going to add and subtract with radicals. So to add and subtract with radicals, the radicands must be alike in the same way that monomial terms must be alike to add or subtract. So similar to when I add 2x plus 3x, the 2 and the 3 I'm just adding, but the only reason I can do that is because they are x's. And because they are x's, that's why I can add them together. When I'm done adding those x's together, it's still a bunch of x's. So the same rule applies here. We kind of think of these as like terms. So do I have like terms that I can add or subtract? So let's simplify each of these expressions. So I have 2 radical 5 plus 4 radical 5. Again, I can think of these as like terms. I have 2 radical 5s and I have 4 radical 5s, which means I have 2 plus 4 radical 5s. So I have a total of 6 radical 5s. Again, I want to make sure that in my radical, I do not have any perfect square factors, and 5 is prime, so I don't have any perfect square factors in there. So we're done. Second one, I've got 2 radical 3 plus radical 6 minus 5 radical 3. I want to make sure I can't simplify these in any other way, and I can't. I'll notice that I have 2 like terms here. These are both radical 3's. So I can do 2 minus 5 with the radical 3 there. So that gives me negative 3 radical 3. And then the radical 6 is pretty much on its own. So I have negative 3 radical 3 plus radical 6. I'm done. So they work very similarly to how we work with our variable expressions when we're adding and subtracting with like terms. All right, let's get a little more complicated here. So let's take a look at radical 54 plus radical 24. Now first what I want to do is simplify each expression as much as I can to see if I actually have like terms. So radical 54, that has a perfect square factor of 9 in there. So I'm going to pull the 9 out, and when the 9 comes out, it becomes square root of 9 is 3. So I end up with 3 radical 6. 24 has a perfect square factor of 4 in there. So when I pull out the square root of 4, I get 2. So I have 2 radical 6. So now these are like terms because they both are radical 6. So I end up with 5 radical 6. Done. All right, this one gets a little messy, so bear with me as we work through this one. I have 2 radical 3 minus 4 radical 45 plus 2 radical 1/3. Ew, that one's going to get ugly. So let's deal with this. I'm going to deal with this one term at a time. So 2 radical 3, no perfect square factors in there. I'm kind of done with it. Negative 4 radical 45. Radical 45 has a perfect square factor of 9 in there. So the square, it's 9 times 5, so that's going to leave me radical 5. Square root of 9 is 3, so I'm going to pull a 3 out there and multiply it by the negative 4. So I have negative 4 times that 3 that I just pulled out. So I have negative 12, which leaves me that radical 5 inside. So right now I have 2 radical 3 minus 12 radical 5, my first 2 terms. This one has a fraction in it, so I have to deal with that fraction piece. So the first thing I'm going to do is split this up into the square root of 1 over the square root of 3. Yes, I know the square root of 1 is just 1. Just bear with me for a second. I can't leave a fraction in the denominator as part. I can't leave a radical in my denominator, so I need to rationalize the denominator by multiplying the numerator and denominator by something that's going to get rid of that radical. So in this case, it's radical 3. So I end up with radical 3 over 3. This becomes radical 3 times radical 3 becomes just 3. So I have 2 times radical 3 over 3. So this is basically 2 over 1. So I end up with 2 radical 3 over 3. All right, back to where we started, which was let's see if we have any like terms here. I have 2 radical 3 minus 12 radical 5 plus 2 radical 3 over 3. Now since these both have radical 3 in there, they are like terms. So this is 2 radical 3 plus 2/3 radical 3. This one's a fraction. We're adding. I'm going to add a fraction to another fraction with what we're doing. I'm not going to work with mixed numbers for this. I'm only going to work with proper or improper fractions. So common fractions is what we call them. So I'm going to change this one into a fraction with a like denominator, common denominator, so that I can just do numerators added together and keep my denominator. Again, another form of like terms here. So since I have 2 radical 3, and I want a denominator of 3, I'm going to multiply the numerator and denominator by 3. Denominator here is 1. So I end up with 6 radical 3 over 3. Again, the 6 and the 3 could simplify down to my original here. So then when I add them, I have 6 radical 3 plus 2 radical 3, which gives me 8 radical 3 all over my denominator of 3. Did you follow that? Minus my 12 radical 5. So this boils down to 8 radical 3 over 3 minus 12 radical 5. That had a few steps. I hope you followed that. All right, last one, a little bit simpler. We're going to dial it back for a minute here. Radical 50 plus radical 18 minus radical 75 plus radical 27. So radical 50 has a perfect square factor of 25. So the square root of 25, when I pull that out, is 5. And I'm left with a 2 inside, because 25 times 2 was my 50. So I have 5 radical 2 plus 18 has a perfect square factor of 9 in there. Square root of 9 is 3. So I have 3 radical. I'm left with a 2 inside there. Minus square root of 75. 75 has a perfect square factor of 25. 25 times 3. So it leaves me with a 3 inside. Square root of 25 is 5. So I'm minus 5 radical 3. And 27 has a perfect square factor of 9 in there. So it's 9 times 3. When I pull the square root of 9 out, I get 3 radical 3. So now I'm going to look for like terms here. These two are alike, so I end up with 8 square root of 2. And these two are alike. I have the radical 3 here, so I end up with a negative 2 radical 3. Whew! Hope you followed all that. So again, what we're doing here is adding and subtracting with our radicals, working to them very similarly to how we work with combining like terms with our variables, except we have to add on to that the layer of simplifying our radicals.